Okay. So let's talk about this. Deploying a working application, a Spring application on Heroku. Okay. It uses Postgres. Okay, so deploying a Postgres Hibernate Spring Boot application on Heroku. Okay, it's actually pretty straightforward, and I'm not like being sarcastic or anything. There's a couple of gotchas that you need to look out for, but for the most part, it's pretty easy, right? So if you go here, I'm going to make a new project. I'm going to use the Spring initializer to do this. So I'm going to do Spring init dash dash dependencies equals web JPA PostgreSQL DevTools mustache. I always forget one of them, so let me double check. I think that's it. I'm going to call it sample Heroku website. All right. So this is the same as if you had gone to start.spring.io and then selected those options and clicked download, right? All right, so I'm gonna go into sample Heroku website, cd sample Heroku website. I'm gonna make a Git repository here just to keep track of stuff. Git commit -m, adding basic Spring project. All right. So now what I'm going to do is open up IntelliJ. I had a student once call it IntelliJ all the time. It was hilarious. I laughed every time and could not explain why. All right. So I'm going to open up the community edition because I prefer it. No. All right, it's booting up, so just give me 1 second. Correct. Yep. It's just a sample thing. I don't know if OBS is recording audio output right now. So what Kelsey just asked was, you don't need mustache for the current project, and the answer is correct. You do not. I was using it as an example. No. The only thing that's going to get loaded is whatever's in your connection string. So, yeah. Hello, Emmeline. Welcome. It is raining quite hard. And my IntelliJ is running very slowly right now, sadly. Wow, I don't think it normally takes this long. Oh, you know what? It's OBS. It's the screen recording software. It makes everything a little bit slower. Just gotta give it some time. No. Basically, there's that dependencies list in the build.gradle file, and you should see like a dependencies block and then like curly bracket, and then like for each dependency there's like a compile and then a string. That string is like the group ID and then a colon and then the artifact ID and then another colon and then the version number should be. You just basically take all that information from the Maven dependency. Like it's the same as the things that are in the XML for a POM file. It's just them squished together. It's like what you like when you added the library in IntelliJ. It's what you added, right? So you just add that as a compile time dependency in your build Gradle and it should work. All right, so let's open up a new project from existing sources. So we're doing sample. Let's refresh. What do I call it? Sample Heroku website. That's what I thought. It's in code, but it's not. Oh, there it is. Could not see it apparently. So I'm going to import it from Maven. Then, that's not a problem. It's the 6 in one that does it in the other, really. The cool part about Spring and Heroku is that you don't actually need a proc file. Your code's just going to work. It's pretty legit. Gosh, this is taking forever. It's just like I'm on Joe's computer right now. Well, I mean, like, was it from 2010, you said? So, well, that's cool, man. Yeah, it's pretty expensive. All right. So the two things we need to demonstrate, using Postgres and deploying to Heroku. All right, so the first thing I want to do is set up my database. So I think it's spring.database.url, and then was it spring jpa generate ddl equals true, and then is that right? You guys looking at the documentation right now? Oh well, yeah, I know that. I mean, yeah, that part is PostgreSQL and then ://localhost:5432/sample project, right? Yeah. Yeah. Okay. We're not going to be using H2 on Heroku. The problem with H2 is that when you make a change, it saves all its information to the local file system, right? That's where the database stores everything. But Heroku's model is such that randomly and unpredictably, it's going to shut your computer down and give you a brand new one. And so since you don't store that database in the source control, it's going to get permanently deleted periodically throughout the day. So for persistence, you typically like to use something other than H2. In this case, we're going to use Postgres. Okay. So let's test this locally. So first, we're going to do psql Postgres to connect to the default Postgres database. I'm going to run a command. I'm going to list, first of all, here's all the databases I have currently. It's a bunch of them. What did I call it? I called it sample project. So I'm going to make a create database sample project call. Okay. And then should be good to go to create my entities and all that stuff. So I'll go here to my com.example package, and I'm going to make a new package that stores all my entities. This is just good practice. It's not required. Inside that, I'm going to store, let's say, a game entity, or game class. Hey, sweetie, this is not food. These are flashcards for second grade homework. You can hold it. Hold on. All right, so first we'll include here. Look, do you want to hold this toy instead? That you really want this for some reason? Okay, you're just gonna mess this up though. So, all right, I guess that's just my life. Hold on one second. I bought these flashcards for Emerson to do math with, and Pepper found them and she wants to play with them. Okay, here you go, sweetie. Please don't ruin this. Ben says with no confidence at all whatsoever. Here you go. You can play with them. It's math. See? All right. Here we go. Okay. All right. So we're going to mark this this class as an entity. Okay. We're going to store information about the table. We're going to say that its name is games, right? And then, yeah, that's it. So for each game, they're going to have an ID integer. And it's going to be, we're going to mark this as an ID. Let's import the class and JavaX persistence class. Okay. And then we're going to say that this is a generated value. Okay. So we have an ID column on game. So if we have a string, furthermore, let's say we have each game has a name, like this is the name of the game. We're going to make this a column. Let's say it's not nullable. Okay. The reason why we don't want to make it nullable is we don't want to have null values in this column for any row in the database. Okay. Oh, Jesus Christ. Just going at it with those freaking flashcards. All right. So let's say we also have like just to stick with what we had in class today, we have nullable equals false. Let's do like int release year, right? So every game was released in a year. And let's say finally we had a genre, right? So every game had a genre, a release year, and name, and that's it. Okay. We're gonna make getters instead of those guys. Cool. So we're pretty standard so far. So with Spring, in order to be able to access this information, we need to create a repository, right? We've been doing this recently. We're going to enter a new package and not call it the package. We're going to call it services. The reason why we're calling it services is because this is where we're going to store like a consolidated location of like our data like retrieval. Like the data doesn't necessarily have to come from a repository. It could come from anywhere. Like we could consume a service like made by somebody else that gives us the information, right? So it's just a generic term for places we get information. So I'm going to make a game repository here. And this is going to be an interface. And it's going to extend CRUD repository, right? And the types we pass into CRUD repository are game and integer. So why game and integer? Well, this specifies that this is a CRUD repository that stores games and is key. The ID type is integer. Okay, so that's what that's about. That's what it expects. So we have our entity. We have a repository for our entity. Now we need to map routes to retrieve that data. So we're going to make a controller so we can begin mapping routes. So let's do a sample project controller. Now none of this is really like beyond what we've done so far. So this should be kind of review, but you know, still might be useful. I know. I'll take care of it in a little bit. So we're gonna move this into there.
I also want some orange juice.
Sweetheart, I'm in the middle of a conversation. Can you wait? All right. So we have a controller here. I love you. So this controller, in order for it to successfully map anything, has to be marked with a controller annotation. Okay? So this is a controller. And now, once we have a controller annotation, we can do cool things like auto wire. So we're going to auto wire a game repository and call it games. And then, furthermore, we're going to have a request mapping.
Bye.
Bye. Path equals slash. And then method equals request method. God, screen recording software is really killer for your. It's like everything's got like a 10 millisecond delay. It's like really frustrating. All right, so in this, we're gonna have a public string, just a home page method, right? And then I'm going to return home, right? So it's pretty straightforward right now. This is a page that, this is the method that just handles the route, the home page route for a GET request, and it returns the home template. And we're using Mustache, so that's how that's going to work. So we're going to go here to new HTML file. We're going to call it home, and we're going to say like sample project home page. Okay, we're going to say, here are your games. And then inside that, it's going to be inside like an H1 or something like that. All right. H1 stands for header 1. So let's run this, okay? To run it, I'm going to run this and establish a run configuration. So what's going to happen now is the Spring is going to start up. It's going to detect the differences between the entities that it has in its class path, like marked here, and the databases that, or the tables that exist in the context database. And it's going to use that difference to actually generate the tables that need to be created to store the entities that you specified, right? So if you make an update to your entities, it's going to want to regenerate it. So we open up pSQL. If we connect to our sample project database, we can actually do this DT command, and well, it has no relations. It hasn't finished starting up yet. I'm ahead of myself. See down here, this whole Spring thing hasn't actually even done anything yet, so I have to wait even longer. I guess you could use that other window as proof that it starts out as nothing, and then we're about to see something else happen there. My computer is not a fan. Oh my gosh, I'm like touching the screen. It is super hot. Yeah, the screen recording software is serious business. All right. Application failed to start. Why? Cannot determine embedded database server. Database type none. Let's look at our POM. Oh, that's all right. There's JPA, Web, Mustache, DevTools, Postgres. What are we missing here? Are you guys sure that I got this exactly right? Data source. No, it's data source. I spelled it wrong. It's not database URL, data source URL. Yeah, it said Spring database URL, which is not correct. When you talk about how you connect to a database, it's always data source. It's a connection string to a data source. I bought a Sports Illustrated copy of Clemson's victory. It's quite nice. All right. Looks like it's working. Yes, ma'am. You have a Postgres, well, I have a Postgres server running on port 5432. I'm sorry? You could override the default, but I would not recommend diving into that. Probably. What do you mean? What localhost to use exactly? Oh, that was the default port for Spark is 4567. Yeah, it's just kind of like, I guess, like the default for Hibernate, not Hibernate. Spring is 8080. The default for Spark is 4567. Postgres sets itself up on port 5432. I mean, it's just not like there's no why you would know it. It's just stuff you learn, right? Yeah, I got it from my brain. Yeah, but pSQL knows to look at that port by default, so it's not going to bother you about a connection string. Like, that's why you're able to just type pSQL in the terminal and it just works, right? It's because it's looking at that data source URL by default. All right, so if we look at /d capital S plus for the games table, like I did here, that's just a pSQL command for analyze the schema. You can see that it indeed has all the columns we needed from our entity. So that's pretty cool. So now let's do something useful. So like for the sample project controller, no, first of all, let's link to like let's just have a form. It's like form method equals post action equals add game input type equals text name equals name type equals input type equals text. Oh my goodness. Name equals genre, and then input type equals text. Wow, that's interesting. Name equals place year. And then, let's see, name, genre, release year. That's it, right? Name, release year, genre, yeah. And then we do input type equals submit, okay? And actually, I think what you can do here, we didn't talk about this in class necessarily, but you can say this. You can say game, I believe, just like that. And then I'll say games.save game. And then, wait, this should not be in our homepage route. Yeah, sorry. We're adding another route for this. So let's add a new request mapping for post requests. So this is on /add game. The method path is equal to /add game. The method is equal to your request method dot post. And then public string post. Gosh, public string post game. We're taking a game called game, and we use games to save game. Then we return redirect /. All right. So in the home page, let's just do this. We need a reference to our model. So we're just going to pass our model in as a parameter. And then we're going to say model.addAttribute games. I'm going to say games.findAll. Okay. And then I'm going to go to our template and then say, let's do this. Let's do a placeholder. Name placeholder is equal to genre. Placeholder is equal to release. Oh god. Place year. Okay. And then let's do a UL and then games, and then li, name, genre, release year, / games. So this is still stuff you've seen before, right? So this is not super complicated. We haven't even used Heroku yet, so that's one subtle complication. But I just wanted to create like a simple, not CRUD app, but a CR app. Not a crap. A create and read app where I create and read data. Okay, so that we can deploy it to Heroku. So that's what we're doing here. Hopefully this works. I think it does work the way I'm expecting. Okay, it's up. So hold on to your butts. Load this. By the way, does everyone know where hold on to your butts comes from? Hold on to your butts. No, there's a. Yeah, do you remember Samuel L. Jackson in Jurassic Park? Okay, all right, that's where I get it from. Okay, so Final Fantasy VII, RPG, 1997, submit. Good. So it did work, right? So we list. We see here in Postgres, it's like select star from games, right? And we see that indeed, yeah, it's in the database. All right. So here's the games. So now that I've made some progress, let's actually sample Heroku project. Git add dot git commit -m doing Postgres stuff. All right. So now that I've got a working CR application, I want to deploy it. Okay. So first things first, in deploying a Heroku application, is you create the application. So you type Heroku create, right? Chug. All right, so I get eveningocean81866.heroku.com. That's fine. So the second thing to talk about with Heroku is that this application.properties file is in source control, so it's going to get deployed, and it's going to deploy with this connection string, which is a problem, because it's going to attempt to look at the local server for its stuff, which is not correct. Right? It's not going to, like, the Postgres server for Heroku is not running locally, it's running on a different server somewhere. Luckily, Peps, hey, stop. Thank you. Luckily, Heroku gives you access to this in the form of an environment variable. So you take this connection string and cut it out. I would cut it in particular because this makes your life easier. So this is how you reference an environment variable. So you do database, or it's JDBC database URL. Okay. I'll push all this code, by the way, so you don't have to worry about it too much. Yes, the casing does matter, because you're actually referencing an environment variable. Are you guys familiar with environment variables? We'll go over environment variables when we get into class on Monday, but basically they're settings on computers. So when Heroku gives you a virtualized computer, it's going to have this variable set automatically for you to be able to read from. Okay? But the problem with changing your application.properties here is that when you try to run this locally, it's going to start screwing up. And there's a couple ways around that, but the easiest thing to do is to modify your run configuration. So you can go here to environment variables and actually specify that, for instance, for the JDBC database URL key, we should give it this value. Okay, so we're including the same environment variable in our run configuration that Heroku is going to create, but it's going to put its own value in for that when it's in production. All right. Yep, I went up here to demo application. Here, I'll zoom in right there. And then I clicked edit configurations. And then I went here to environment variables. I clicked the ellipsis here, and I clicked the plus sign that's down here. Hold on. The plus sign here. And I typed in what was there, right? So JDBC database URL. And then I typed in what I cut from my application properties. I put that there. Okay. Yeah. As the connection string, right? So it makes sense conceptually because we're replacing basically the hard-coded connection string to localhost with an environment variable that changes per environment. Yeah? Okay. That's cool. All right, so once we have that in place, we're pretty much all set, actually, with the Spring application. So we're going to do git add dot, we're going to do git commit -m, adding Heroku-specific run stuff. And then, you know what? Let's just give this a shot. Let's rerun our application. Remember, we're running this specific run configuration. And just make sure it all works still. Because it's possible that I got this part wrong. Like, there's so many different little macros for how to replace stuff. I just need to make sure. So I'm not going to deploy to Heroku just yet. Yes, exactly. And you don't have to worry about really much of anything. It just uses the right thing based off of where it is, you know? Yeah, it's pretty legit. All right, so it started. So that's encouraging because it wouldn't have started if it messed up. And we refresh, and it's done refreshing. It's just listing the same thing. Let's just prove it. So let's do that. So good. Yep. So everything is still being added locally. And then we've added everything we needed to Heroku. Well, we added it to Git, sorry, not Heroku. So when we deploy to Heroku, it's just git push Heroku master. So if you have your work, by the way, on something other than the master thread, Heroku is going to push that. It's not going to allow you to deploy it unless it's on the master branch, so watch out for that. There are ways around that, but y'all aren't ready to do that yet. Watch out for your terminology there, Emily. If you're on a branch, you need to merge it to master and then push. Yeah, okay. Yeah, you don't push it to master and then push it anywhere else. Just a small, slight difference in that. Okay, so once you have that, and if you don't want to remember this, you just do Heroku open, and it'll open the page that your app currently references. So normally I'll look at the log files, but I'm pretty sure this is going to work. So you wait for the dyno to boot up. Yay! Refresh for. You're like, Ben, 9986. And it works, right? So we have a working web app pretty quickly on Heroku with Spring, right? Now, the one thing you're going to want to do a lot when you're working with Spring and you're changing your Postgres databases a lot is kind of reset your database URL, or kind of reset your database, right? Because it's going to have a certain schema, and then you're going to change something, and you're going to want to update. Now, to connect to Heroku's database that it establishes for you, you type this. You do Heroku pg:\psql, like so, okay? this is how you can use pSQL to connect to your specific Postgres instance. So if I hit enter here, all right, so now I'm in a database. If I type /L, you see this really interesting prompt, which is databases. These are all databases owned by other people, okay? They're all given random database names. They all have random owners. It all is totally random. So you're not meant to connect to a different database. You are already on the database that is given to you. So if I do /DT, I see my schema, right? And according to the database, this is the owner of it. So they randomly generated the owner name, randomly generated the database names. They make it pretty secure. So like even if I wanted to mess with somebody else's stuff, I couldn't. But you can see how, like, you see the schema there, and if I did the same thing that I did locally, where I do that's plus games, it's got the same columns there, and if I select everything from games, I see the same thing that I entered in on the public website. Okay, so that's Heroku. That's how you can connect to Heroku. If you want to reset the data in your Heroku instance, which is a very common operation, because you can't just drop the database, because it's a very strange operation. You can use Heroku PG reset. Then you give it a database URL, like that. So this is a fairly destructive operation, so it's going to try to make sure that you want to do it. I mean, by fairly destructive, I mean it's very, it destroys all your data, right? So if I do this, it's going to be like, hey, are you certain that that's what you wanted to do? And so what it's making you do is type the name of the dyno, right? It's like, okay, if you're sure about this, type evening ocean 81866, right? You hit enter, it indeed resets Postgres for you. So once you have that, you can see that if I refresh this, it's actually going to take a sec probably to boot up again. It might just break. I don't know. No, not exactly. So say you wanted to, like you changed your mind about how many columns were in an entity or how you related two entities together. Hibernate would not destroy your existing tables or modify them if it saw that it already existed. So your code would assume the changes were made, but then the database, it wouldn't get sent to the database. So to basically start your database from scratch so that it doesn't have any existing tables, it tells Hibernate that it needs to make them, right? And so Hibernate will make them for you. So if you change your entities, you likely will need to reset your database for now. I think there were some questions in class about ways around that. And we can certainly go over that, but for now, it's just the easiest thing to do is just reset it from scratch because you don't have any important data to store. So actually, let's look at our logs. So we can do Heroku logs tail. It shows us updated logs whenever anyone hits our website. Looks like we have a significant amount of errors here. Heroku is just, or pSQL just is messed, or Postgres is messed up. So let's do Heroku PG pSQL here to connect to our database to confirm that it exists. All right, let's just make sure that that still fails. Okay, so the database connection failed, and now it basically tripped up our application. So essentially, we need to redeploy our application. Which the way we can do that is say Heroku PS scale web equals 0. So this is going to scale our number of web dynos down to 0, so that basically our app isn't going to run anymore. Essentially, we're restarting our application. Right? So once we set it to 0, we can see that we refresh this page, and we get a totally different error, which is just a Heroku error, which basically means that our app isn't running. Right? So if we scale that back up to 1, essentially what's going to happen is it's going to progressively just start our application again. And we can look at the progress of our application starting if we type Heroku logs -- tail. So we see here, it's booting up just like we saw locally, right? This is just the same output as before. It's just happening on a Heroku server somewhere. Okay, so it began. So it said state change from starting to up. That's the key thing. That means it's up and running. So we're going to refresh our application, and we see indeed that we have our games, and it's been reset. Okay. Boom. So we're all back up and running. So we know how to use pSQL to get to our database. We know how to reset our database to a fresh state. We know how to deploy, and we know how to add the configuration to the application.properties file, and we know how to add the environment variable to our run configuration. So with all of that, you should be able to deploy your application using Postgres effectively. Any questions? Okay. Yeah, well, that's the kind of point of this, is to make it so that you can focus on the logic instead of being tripped up by the logistics of getting this up and running. So hopefully this assists you in that somewhat. Sam and Joe, do you guys have anything to add? No problem, man. It's okay, Sam. I actually am recording this thing, so I'm gonna, after we get off this hangout, I'm going to upload it to YouTube so you can just watch it at your discretion. Yeah, man. All right, folks. Thanks for stopping by. Good luck. Yep. Bye.